All right, let's go over Chapter 7, which begins in your book on page 265. It's called Using Methods. You know most of the material in here. In other words, you've already written methods with no parameters. You've written methods with no return type. You've written methods that require a single argument. You've written methods that require multiple arguments. You've written methods that return values. All right, so basically what's new is implementation hiding, passing arrays to a method, understanding some alternative ways to write a main, and talking about some of the issues with using methods in GUI programs. All right? That's nice. All right, so when you call a method, it's known as invoking the method. All right, so it's a method call or it's a method invocation. Okay, just so you know. A method is a series of statements that ideally carry out a single task. Think about this. If I have a form on my screen and that form has 10 elements on it, first name, middle initial, last name, address, city, state, zip code, social security number, let's just, all right, 9 elements, and some kind of a cell phone number. In an ideal world, you'll write that as 9 different methods. Does that make sense to people? A method is only supposed to do one thing. It's not how the world works, and that's not how most people write methods. If they did, you'd have a lot less code problems, but still, that's not the way that most people do it. Now, they talk in here about arguments, and they talk about parameters. It's not really that big a thing, but one thing to realize, if you would please look up on the screen here, this is figure 7.1 from the bottom of page 266. There are 2 methods in this program. The first method is main. The second method is writeLine. So the writeLine method is embedded inside of the main method. So it is local to the main method. Does that make sense? All right. It's just some terminology that gets used. So main is the calling method. writeLine is the called method or called method. All right. Then on the next page, and again, I don't want to read to you, but they talk about implementation hiding. That's one of the hallmarks of this stuff. I'm asking you this question. I'll tell you the answer. As far as I'm concerned, the answer is no. Okay? But when you call this statement right here, when you call that statement, this one in blue, I'm asking you, do any of you know physically what happens in the computer to make that write hello on your screen? Do you know how that works? I don't have a clue. It's hidden from me. There's no reason for me to know it. That's an example of implementation hiding. We go through our lives that way. You do, when you think about it, every day you do dozens of things that you probably don't know how they work. Luke's keying stuff in on his keyboard right now. Does he know when he keys in something exactly what happens to make that appear on the screen? Again, I don't know. I don't care. All right. Sometimes this hiding the implementation methods is known as a black box mentality. All right. In fact, computers used to be known as black boxes. All right. Because they just did magical things and most people didn't know and didn't care what they did. All right. All right. Again, why do you write methods? Okay, there's 2 main reasons that you write methods. One is so you can take your program and you can break it down into a series of subprograms. In other words, so you can modularize your program. 2, so you can call the same code again and again. All right? What you want to do with methods is you want to alleviate what's called code bloat. And that's when you repeat a lot of the code in several places in the program. If you find yourself doing that, all right, if you find yourself doing that, it means that you're not writing very good code. All right. Now, if you would please look on page 269. Take a look at that picture at the top of the page. The line that they're pointing to there that says private static void show welcome message. That line is what's known as a method declaration. All right? It's got private, and that's what's referred to typically as the access type. Talk about that in a minute. Then it's got static, which may or may not be necessary. If this method is going to interface with main, typically since main is static, any method that interfaces with main will also be static. What does void mean? It's the return type, but what does void mean? I'm asking you, what does void mean? There is no return. It's void of a return. In there, what is show welcome message? What is that? Yeah, it's the name of the method. You can tell by looking at it that the method takes in no parameters because there's just an open and closed set of parentheses. All right? The method, after the method header, you've got a set of curly braces. That's the delineators, the bookends for the method. And in between those curly braces is the method body. All that makes sense? Because some of that may appear very well on your test. All right? So they talk about accessibility next at the bottom of page 269. And accessibility just basically means who can see what. If you have public accessibility, everybody can see it. If you have private accessibility, only that class in which is defined can see it. Now in the next chapter, in chapter 9 and 10, we will go over object-oriented programming. And we will talk about protected. So imagine with something that's public, it's like a public figure, available to all. In my house, you could kind of look at me as being the private figure. I'm available to everybody in my family. If I was protected, I'd be available to everybody in my family, and I'd be available to anything that inherited from me, my kids, and anything that inherited from them, my grandkids. All right? And that's what they're saying here on the bottom of page 269. All right. Let me ask you a question. If you look up on the screen here, I'm just going to put a little bit of code up here. You already know the answer to this. Why do we put it? Put one more of these in there. Why do we put this in our code? It's not a trick. Why do we put that in our code? The amount of typing, right. Because that means that when we do that, we can write line, hello. And if we didn't write that, we have to say system.console.writeLine. You can still do that even if you put in the using. It's code bloat, but you can do it. If you put in something that looks like this, that's called a fully qualified name. It's the system class and the console class under the system class, and it's the WriteLine method. All right? So on page 270 in the text, on page 270, the author kind of explains this, what a fully qualified name is. All right. Static is probably the hardest thing to understand. Really, it's probably harder than arrays. Probably the hardest thing we've had to understand so far. And it says the optional static modifier. Not always optional. All right. It says you can declare a method to be static, which means you put nothing there, or non-static. All right. I'm sorry, if it's non-static, you don't put anything there. If it's static, you put the word static. So if you use static, it says that you can just call the method. You don't have to, you don't have to call an object of the method. Now, it might sound a little weird, so let's look quickly at an example of that. You haven't seen this yet, but there's a bunch of built-in methods and a bunch of built-in stuff inside of C#. For instance, would it make sense, looking at the screen there, that you could use that to get the value of pi? Does that make sense? Math.pi. But you don't have to create an object. You can just use it. All right? It's part of the math class, math dot. So it's part of the math class, but you don't have to do anything special to use it. All right? So it is automatically static. And that's what they try to explain on the bottom of page 270 and on the top of page 271. Okay? And I'm not saying that's going to totally make sense. I'm not going to say that that explanation was, boy, that was a great explanation. No, it wasn't. All right, but I'm trying to keep it as simple as possible. Every method has a return type. The return type is known as the method type. You already know we talked about void, but you can have any return type. Any of the numeric types we talked about, the Boolean type, the char type, the string type. You can return an array. All right, you can return basically anything you need to return. On the bottom of page 271 and going on to 272, every method has a name that must be a legal C# identifier. Period. Again, I'm going to let you read this. Some people call, when you call a function, so if I do this, if you look up on the screen here, again, I'm trying to make this, believe it or not, as simple as possible. So let's just say inside of main. So I've got static, all that other good stuff. But I come in here and I type in this. Int x equals 7. Int y equal 10. Int sum equals add 2 x, y. All right. Then down below that, I come in here and I write, I don't know, private int add 2, int number 1, int number 2, and I say just simply return n1 plus n2. Looking at that, does that make sense to everybody? What that'll do is it'll add 10 and 7 and return 17. Does that make sense? All right. If you look on the screen, some books call these parameters and these arguments. Some books call these arguments and these parameters. Some books call them both arguments. Some books call them both parameters. If you're computer people, about the only thing you can be certain of is there won't be universal agreement among anything. It's just the way it is. All right. So that's what they're mentioning there on the top, or I'm sorry, on page 272. All right. They talk about placing a method in a class. I wouldn't worry about that right now, because that's what chapters 9 and 10 are about. I already mentioned that when we put the right line method inside of main, then a right line became local to main because it was inside of main. Now she does have examples in here, and the first one is on page 273. You should be able to look at this right here and know that it's calling here show welcome message, so it should say welcome, have fun, enjoy the program, then it should say hello. And that's exactly what it does. I'm asking you this question, true or false? Could I take this line of code right here, this line that you see in kind of gray and blue, the line that says show welcome message, could I put that into a for loop and call it 5 times? Could I do that? What? Yeah, why not? Then it would say, welcome, have fun, enjoy the program, hello. Welcome, have fun, enjoy the program, hello, 5 times. Then it would say hello. All right? So yeah, again, that's one of the reasons that you create methods, is so that you can call them repeatedly if you need to do that. When you declare variables inside of a method, they're known only inside of that method by default. So they're local to the method. Now they talk about constants. Most books will tell you that it's considered best practice if you're going to declare constants, declare them at the top of the program. Make them global. All right. On page 275, the author has the first in the chapter of her you-do-its. So notice what it says. Write a program in which a main method calls another method that displays a company's logo. All right, so main calls display company logo, which will write these two things. All right, and that's what you'll get. So she explains what she's going to do on page 275 and runs it, and then gives further information or explanation on 276. Next are methods that require a single argument. Some of them do. By default, how many arguments do you add to WriteLine? 1. Here's a question. Think about it. How many arguments do you provide for ReadLine typically? None. Correct? All right. So there is an example of a method, one method that takes one argument, typically, by default, and one that takes 0. And they explain all that on the top of page 277. Now, this is important. It's probably going to make its way onto your test. All right, if you look up on the screen, please. Right here, those two things, X and Y, they're called actual parameters. That's their actual name. These two right here, N1 and N2, those are called formal parameters. True or false? I could have made this X. I could have made this Y. Oops. And I could have said return X plus Y. True or false? Yeah, I could do that. The reason I don't do that is what if I want to come down here later and say, or earlier, int A equals 21, int B equals 22, int, we'll call this sum 1, equals add 2 A, B. And then we'll call this sum 2. That's also legal. But you'll notice I'm calling the add 2 method twice. In the first case, the actual parameters are A, B. In the second call, they're X, Y. But in both cases, the formal parameters are N1 and N2.
We're going to learn how to use the math class.
We'll look at it a little bit. Okay. I'd say not really a whole heck of a lot. And it typically doesn't have as much in there as you probably think it does. All right. Now, this thing that they show here on the screen, and it's on the bottom of page 279, all right, you may or may not remember, this whole thing was shown back in Chapter 2. And all it's talking about is what's called conversion. So if I add an int to a double, I'm like trying to add an apple to an orange. So what happens is when I go and add the int to a double, the system will promote the int by putting like a 0.0 on the end of a copy of it, and that's what it'll add. So it's adding a double to a double. And that's what they mention here on the bottom of page 279. All right. Not only then can you have methods that have a single argument, you can have methods that have multiple arguments. Either ones you write or built-in methods. I'm asking you this question. Look on the screen. Not meant to confuse you. How many arguments does display sales tax require? 2. And they both have to be doubles. What is this returning? Nothing. That's why its return type is void. All right? And that's what they talk about down here. Okay? All right. Give me about 10 more minutes. We should be able to finish the chapter. Then we'll take a break. After the chapter, I'll hand you out the review for the Chapter 7 test, which will be next week, and the rest of the period will be lab. All right? She's got her 2 truths and a lie. In fact, let's go back to that. Let's look on the bottom here. Look on the screen, if you would, please. Does this make sense? Since you're returning a double, and since what you're returning is gross, gross must be a double. Does that make sense? You're returning a double. That's the name of the variable you're returning. So that variable must be of type double. Does that make sense? Well, yeah, it does. Okay, good. That's the question. Return statement, as it says on the top of page 283, causes a value to be sent back to the calling method. That's its job. We look at the example here on page 283. Notice here we're calling calc pay. Right there, it's kind of dark. We're passing it in my hours, which is 37.5, and my rate, which is 12.75. All right? The name is calc pay. It's expecting 2 doubles. It gets it. It says the gross is equal to this. Okay? And it returns it. Here's a question. I'm going to just grab all this. And if somebody please at least attempt to answer this. All right? Of course it did that. All right, if you look up on the screen, again, this is not meant to confuse you, okay? Everybody sees what this looks like. I'm asking you, could we just as easily have done this? Could we just as easily have done that? Not only could we, that's really the recommended way of doing it. Why? Because here we've got 1, 2, 3, 4, 5, 6 lines of code. Here we have 1, 2, 3, 4 lines of code. In the first case, we're creating a temporary local variable we really don't need. There's nothing wrong with doing it, but you're making more work for yourself, for lack of better words. .284 here, if you look, it's halfway down on the page. If you look at this line, all right, does everybody realize there's 3 method calls in there? The first thing that's going to happen is the read line. The output of the read line becomes the input to the convert.toInt32. The output of that becomes the input to get price. So we are nesting method calls. We have a method call within a method call within a method call. There is literally no limit to the amount of nesting you can do if you want to or need to do that. All right. Now, James, this is about as close right now, at least, as we'll get. But analyzing a built-in method, this is the bottom of page 285. If you look up on the screen, the author says if you look at that line of code right there, double result equal math.pow 2.0, 3.0. What that says, to be honest with you, is result equals 2 cubed. 2 times 2 times 2, or 8. But it says by looking at that, you should know that pow is part of the math class. Why? Because of math.pow. You should know it's public, and you should know it's public because we didn't have to do anything special to be able to use it. We should know it's static because it's the name of the math class, not an object, .pow. We know that it accepts 2 parameters, and they're both doubles. Since it's going to multiply one by the other, and it's double times double, we know that it returns a double. All right? So that's what the author is saying. Just by looking at that line of code, you should be able to understand how it works. All right? And she's got another of her you do it's. So again, if you're looking at this and you're confused, look at the you do it on 286, 287, and 288. Writing a method that receives parameters and returns a value. She gives you a prologue over what she's going to do. She does it in here step by step. Then she writes the main. Then she writes the call. And then she shows you what the output should look like. All right? All right. As we get down to the end here, about 10 more pages, sorry. Passing arrays to a method. Look on the screen, please. What I want you to understand is if you pass a single array element, just one element in an array, if you pass that to a method, that's just a variable. Does that make sense to you? So you're just like any other variable, just like the x and y. So any change you make, it's a temporary change. On the other hand, this is what the next chapter is about. If you pass an entire array to a method, you pass the address in memory of where that array lives. So when you pass an element, it's known as pass by value, call by copy. If you pass an entire array, it's known as call by reference or pass by reference. When you pass an array to a method, an entire array, any change you make in the method is a permanent change. That's the bottom line. The author shows this on the program. It's on page 291. All right. All right. Just about finished on page 293. Alternate ways to write a main method header. Okay? You've seen, main written like this all the time. Static void main. And there's nothing wrong with writing it like that. You can also write it like this. Static void main string bracket bracket args. In fact, if you look at that, this is halfway down on page 294. All right? If you do it like this, I guess it's 293. If you write it like this, that's how you do it exactly how you do it in Java, right there. Except I believe in Java the word main is lowercase. All right? Why would you want to do that? If you do that, that says that main can have a string array passed into it called args. Why would you want to do that? Because when you run the program, you can pass things in to the program. And you're like, do we have to care about that? Absolutely not. All right? Other than to let you know you can do that. You can also write main so that it returns an integer. So instead of saying static void main, you can say static int main. Why does that matter? That's how the C programming language does it. All right? So you've got a lot of different ways that you can do the same thing. Page 294, and this is the last thing in the chapter, issues using methods in GUI programs. The biggest issue is human beings are running the program. If you write yourself a console program, you can say exactly call this, now call this, now call this, now call this. If it's not a console program, if it's a GUI, you can tell the user click this button, then click this one, then click this one, then click this one. You have no ability to make sure they do it that way, in that order, and they click all those buttons. That's what the author is talking about in here. All right? Some things are generated automatically in a visual environment, like click events. As soon as you click something, boom, that event fires. Appreciating scope in a GUI program, which is on the middle of page 296. All right? When you create event handling methods in a GUI app, you must constantly be aware of which variables and which constants are needed by multiple methods. If something is, if you've got a variable that's needed, let's say you've got a program that's got 10 methods in it, and that variable is needed by all 10 methods, you'd probably make it global. All right. And finally, creating methods to be non-static when associated with a form. Sometimes you want to make things non-static. That will be more often in a GUI program than it will be in a non-GUI program. All right, hold on a sec.